right? Develop your hypothesis, develop your assumptions, and that will be the second project after this project. Okay, we will start that. Now, this first project, we are spending significant amount of time to understand each step in a very detailed manner. Now, for the second project, okay, so I would expect you guys to at least complete these steps. Importing the data set, descriptive exploratory data analysis, reading the data set, understanding the structure, and then we will look at building the machine learning model. Okay, so now this cross-sell model that we are discussing is a classification problem. Right, so this क्या है? Now this data set that we are talking about is about cross-selling. Our target or dependent variable is whether the customer will say yes or no for buying the term deposit. ओहो, तो लाइट चली गई. हेलो.
Yes, sir. Yes, sir.
हाँ. See, the pad, writing pad which I was using, na, the power went off. Now backup is getting activated. Okay. So term deposit. Okay. So the outcome here is yes or no. Now these kind of problems, right, in machine learning, they are called as classification problems.
Sir, are you
Hello?
sharing something?
Yeah.
Yes. Acha, you are not.
No, it's not visible.
Okay. I have not shared. Sorry. Are you seeing this?
Yes.
Yes,
Okay.
sir.
Yes. Sir.
Okay. So yeah. Now this is a cross-selling problem. Okay, you want to sell more products to your existing customers. Now in this data set, our target variable, dependent variable, is whether the customer will accept the term deposit or not. So outcome is yes or no. Right? So we would like to classify, right, the possible values the target variable takes is yes or no. So these kind of problems are called as classification problems. Now let us, so the next case that we are going to discuss is customer churn. So what possible values this particular variable will take?
Yes or no?
Yes or no, right?
Would we retain him or would we lose him?
Whether he will leave the bank, the organization, let us say, right? So any organization, whether he will leave or he will stay with the company. So that is customer churn. Now, after customer churn, retention strategy comes into the picture. You send an offer, like let us say आपने telecom में port out किया, okay? You requested for a port out, and immediately you get a call from Airtel or Jio or Vodafone, whatever that may be. They give you the offer, okay? So that is retention strategy in practice. So they are giving you the offer. Now the outcome is whether you accept the offer or whether you reject the offer, which means whether you stay back or whether you still exit. Okay, so all of these problems, they are classification problems. Now, the entire approach of building a predictive model, which we are going to build for cross-sell, right? The steps, entire steps for all these kinds of problems, classification problems, will remain the same. Okay, now, if you have gone through that Titanic data, what are they trying to predict?
Would he survive or not?
Right. So passengers who were on Titanic ship, whether they survived or not survived. So is it a classification problem?
Yes.
Yes, sir.
Right. Right. So
Yes, sir.
this
Yes.
also is a classification problem. Now again, building a predictive model for this, you take exactly the same approach which we are taking in this cross-sell model. The point I am trying to make, in life, in practice, okay, you will face classification problems. Most of the times you will face classification problems, and again, this is I'm giving you the statistics from a SaaS person or an IBM person, right? The analytics project which involves classification problems for almost all kinds of organization is anywhere between 30 to 40%, which involves classification problems. Okay, then you have forecasting or regression problem that is around 20 to 30%, and then there are other machine learning problems. But if you are able to appreciate classification problem as such in general, then you come to marketing or you come to operations or you come to finance, right? Almost 30% of the analytics projects deals with classification. Binary classification or multiple classifications. Okay, so now this is classification. So what are the other? So you have classification, you have category, categorical variable as a target variable. Then another form of business problem is your forecasting or regression problem. Here you predict continuous variable. Here you are predicting categorical variable. Okay, and the third form is wherein you don't have any target variable. And those kind of problems are your clustering problems, or dimension reduction. You want to reduce the number of variables or features in the data set. Okay. Now, these kinds of problems in machine learning, they are called as supervised machine learning problems, right? Now, the simplest thing to understand is the mere presence of your dependent variable or a target variable or a variable which you are trying to predict. Okay, those problems you classify it as machine learning problem. Now supervised machine learning problem, and within that, now within that you have classification problem, and the second type of problem is you have forecasting problems. Okay, your supervised machine learning problems. Now the clustering problems, or in marketing we have segmentation, we do RFM, using RFM we do segmentation, and there are various other aspects of segmentation where there is no presence of dependent variable or target variable. You are not trying to predict dependent variable or target variable. Similarly, for factor analysis or principal component analysis, no target variable or dependent variable. What you are trying to do is you are trying to represent the data by using less number of variables. So such kind of analysis, such kind of problem, you call it as unsupervised machine learning problem. Right. Now another way, I'll just give you an example of, just to get an understanding, a better appreciation, right? Let us say we have features of, let us say, some kind of fruits. We know what are the dimensions. Okay, so this is, let us say, apple, orange, pineapple. Now we are dealing with kind of data wherein we are to, based on the dimensions or features of the fruits, let us say height, width, shape, we want to predict whether that fruit is apple or orange or pineapple. What kind of problem will this be? Will this be a supervised machine learning problem or unsupervised machine learning problem? Yes.
Sir, it's supervised classification problem.
Yeah. So why? How?
Unsupervised cluster.
Huh. Harsh. You were Harsh, na? Kaun tha?
So Pratik here. Actually, I was saying ki we are forming cluster, right? Apples, oranges, and
Huh. But see, अभी let us say this is the data set. अभी मैंने आपको z दिया, एक एडिशनल z1 दिया, एडिशनल x1 दिया और एडिशनल y1 दिया. Okay, now I am asking you, tell me whether this is apple or orange or pineapple. So
Sir, it is supervised.
so you need to tell why. You need to tell why.
Sir, it is supervised because we have already stored what should be given as an output when we give any input to the system. So
Right.
the system already knows that this output, this output should be given.
Exactly. So we have, we have this as an input and we have this as an output. Okay, this is your target variable. Now this is what you would like to predict. So you will, after you have built a model, you will say, okay, this is A, this is O, and this is P. Okay. Now this becomes your supervised machine learning problem, and within that this becomes your classification problem. Multiple classifications. Okay. Now let us say I remove these labels. Okay. Now I am telling you, identify fruits which have similar dimensions, which are closer to each other, but I am not giving you the names. Now, in that case, what kind of problem it is?
Okay, so then it becomes a unsupervised learning. Then we have to define that given these, the machine will segment them on the basis of some dimension that it found, and then we have to interpret that how it has segmented them.
Exactly, right? So
So
now
maybe we can directly say that in this situation, machine will take the decision based on whatever data that is pre-stored. Like the height, it will go stepwise and take its own decisions.
Right? So okay, so let us assume there are three features. Okay, let us say there is height, there is width, and there is breadth. These three data is there about the fruits. But we don't know, let us say apple ka height is anywhere between 2 to 3 inches, width is anywhere between 1 to 2 inches, and breadth is anywhere between 0 to 1 inches. Okay, so this is the possible range. What we try to do is identify elements which are similar in nature. But we are not telling the machine, okay, identify whether it is apple or orange. Okay, so what the machine will do, we ask the machine using an algorithm, okay, we ask the machine identify similar fruits, okay, right? So it will use height, width, and breadth, okay, and it will tell us these three things, y1, y2, y3, and z1 and z2. So what it will do, it will cluster these shapes at one place. Okay, these are similar elements, these are different elements, right? And that is when we don't know, we have not given the machine the information, okay, tell us this is A, this is B, and this is C. There is no target variable in the data set. That kind of problems becomes your unsupervised machine learning problem. And then the classic example is your k-means clustering, right? So that algorithm is dominantly used in practice to handle all kinds of unsupervised machine learning problems. I hope there is a clarity on this. What do you mean by supervised machine learning problem, and what do you mean by unsupervised problem? Haji. Hello.
Yes, sir.
Yes, sir.
Okay. Now, so we are talking about supervised machine learning, and we are talking about unsupervised machine learning. Within that, we are talking about classification. Within that, we are talking about forecasting or regression problem. Now we use different algorithms. Okay, let us say for classification, there are different algorithms to predict. One is your logistic regression. Then you have decision trees. Then you have random forest. Then you have support vector. Then you have KNN, K-naive bias. Right? And there are so you have artificial neural network.
सर रेगुलराइजेशन और फिर वो क्लस्टरिंग भी तो आ जाता है ना, KNN और फिर K मींस क्या क्या आता है?
See. K means he will come here, Mudit.
हाँ दोनों अलग अलग। हाँ
Artificial neural networks.
हाँ
Then you have bagging and boosting algorithms.
सर डीप लर्निंग भी तो है,
नहीं
ANN के
वो
अलावा डीप उसमें कॉन्वोल्यूशन वो
see
सब काम नहीं होते।
see deep learning we will touch upon that but not get into deep learning. See, deep learning basically is to handle unstructured kind of data or problems which you are trying to solve using unstructured data.
ओके ओके
Right?
ओके
Yeah.
सर
So
ये अपन एसोसिएशन देखेंगे क्या, एप्रियोरी वगैरह काम का है अपना?
so वो see that काम का है, जरूर है, क्यों नहीं है,
नहीं फॉर द कोर्स इसके लिए।
हाँ नहीं कोर्स में सी वो मार्केट बास्केट एनालिसिस व्हाट इसने रश्मि सर ने बोला था कि ही विल कवर एंड वो दोज अ प्रायरी एल्गोरिथम्स, सो वी विल, आप मुझे बताओ इंक्लूड करना है तो आई विल इंक्लूड दैट, बट एज ऑफ नाउ माय
वर्किंग केस अपना ऐसा अगर कहीं यहाँ पे हो रहा होगा तो फिर मैं याद दिला दूंगा कि ये काम भी अपन
ओके
कर सकते।
सी आई टेल यू व्हाट इज द प्लान। इसमें ये क्लासिफिकेशन में एक प्रोजेक्ट डिटेल में करना है, ओके और एक प्रोजेक्ट मैंने जो अभी आपको डेटा शीट दिया है, आई विल आस्क यू टू डू इट एंड देन आई विल क्विकली रन थ्रू द स्टेप्स बिकॉज इट्स लाइक अ रिपीटेशन, okay, and you get a second practice, you get a second case study and you also get a feel, okay, कि दोनों का approach more or less similar था. Then the third case study which I plan to discuss is the forecasting problem. Either it could be sales forecasting, it could be revenue forecasting and a revenue problem, and then I will share 2-3 case studies which are similar in nature and which you take similar kind of approach, so you get a feel कि okay ये problem handle किया, अब हम इसी तरह के 3-4 different problems भी यही approach लेकर के handle करना है. And then the next project I plan to do in the class is unsupervised RFM data. Based on RFM data, how do you create segments or clusters of customers? So that's the plan, Mudit. Okay, so now now these are the machine learning algorithms which we will be using in this cross-sell models as well. Now your earlier approach जो आपने इसके पहले पढ़ा है, let us say आपको churn model दिया, तो what will you do? You will run logistic regression, you will find accuracy and you will stop there. Okay, the different thing that is happening in today's world is you are using this algorithm and you find out predictive accuracy of this. You use this, you find out, you evaluate the model. You use random forest, you evaluate the model. You use support vector machine, you evaluate the model. You use this, you evaluate the model. You use this, you evaluate the model. Now, what you are doing is you are trying to predict y, okay, in this kind of problem. So y for all possible 10,000, 20,000, whatever customers you have. Okay, so you get an additional column. Okay, so you have this prediction here. Let us say आपको ये लॉजिस्टिक का प्रेडिक्शन है, दिस इज डिसीजन ट्रीज का प्रेडिक्शन, दिस इज रैंडम फॉरेस्ट का प्रेडिक्शन, दिस इज ANN का प्रेडिक्शन. ओके, नाउ this is customer 1, 2, 3, 4, 5, 6, 7. Now, based on your model, this model is telling you, yes, this will accept. This model is telling you, yes, this will accept. And let us say random forest and support SVM, support vector machine. Okay, Y, N, N, right? Similarly, you have Y, and so on and so forth. ये मॉडल बिल्ड किया, उसके बेसिस पे ये प्रेडिक्ट किया. ये मॉडल बिल्ड किया, उसके बेसिस पे ये प्रेडिक्ट किया. ये मॉडल बिल्ड किया, उसके बेसिस पे ये प्रेडिक्ट किया. ये मॉडल बिल्ड किया, उसके बेसिस पे ये प्रेडिक्ट किया. राइट? नाउ in practice, what you are doing is you evaluate the accuracy for each of this model, and you decide, okay, whichever model is giving you better accuracy, and this is what we are going to do with this data. Okay, let us say random forest is giving you better accuracy, 90% accuracy. All others are giving you 85%. So you go with random forest and you implement this model in practice. Or what some of the analysts they are doing, they take a vote. Okay. अरे क्या किधर गया ये?
सर टॉप में रहेगा सर, लेटेस्ट डेट सर.
ओके.
दिसंबर
नहीं, किस में रहेगा ये? 7 दिसंबर ना इसमें?
सर लेटेस्ट डेट सर.
हाँ, हाँ. So they take a vote. Okay, and here let us say 3 models are telling you, yes, this customer will accept term deposits, and 2 models are telling you, no, this customer will not accept the term deposit. So you finally say why. Similarly, let us say 4 models are telling, okay, this customer will not accept. 1 model is telling this customer will accept, and you finally conclude, okay, this customer will not accept. Okay, this approach you call it as ensemble modeling. You create an ensemble of models. Okay, this is also we will try to learn using the data set. Is there a clarity? Let me know if you have any questions. हाँ जी.
सर ये ensemble क्या है?
See, we are creating an ensemble of the models. What we are doing, हम 5 in real life, imagine, let us say you are 5 friends, और आप decide कर रहे हो कि आपको, let us say you want to go to Kashmir, right? And 3 friends are telling कि yes, we will go, and 2 friends are telling no, we will not go. And you go with the majority. The same approach we are taking. We are taking models, 5 different algorithms, and building models. Based on that, you are predicting, okay, this customer will accept the term deposit or not. Now, based on this, 3 algorithms or models are telling you, okay, this customer will accept the term deposit. The another 2 models are telling you, no, this customer will not accept the term deposit. Right? And then you finally conclude, okay, yes, based on this 3 models. So what we are doing, we are creating 5, we are using 5 algorithms. We are taking the vote of that algorithm and then finally concluding why yes, based on majority. And there are different ways of creating this ensemble of models. The idea is to understand what do you mean by ensemble modeling. And for these data science and machine learning roles, in interviews, you will definitely get a question on your understanding of what do you mean by ensemble modeling. So this is one of the way. And yes, of course, there are 2-3 different ways. We will do that in using R, right? I hope I. Okay. So let us come back to our data set. ओके सो हमने क्या क्या किया था लास्ट क्लास में
सर डेटा इंपोर्ट किया था
हाँ हाँ पूरा स्टेप्स बता दो शुरुआत से एंड तक
सबसे पहले हमने डेटा क्लीन किया था मतलब
मुदित एकदम शुरुआत से
ओके सबसे पहले हमने वर्किंग डायरेक्टरी इंपोर्ट वर्किंग डायरेक्टरी के बाद जो भी डेटा सेट था रॉ डेटा सेट उसको हमने कन्वीनियंस के लिए डेटा सेट में मतलब उसका नेम डेटा सेट में कन्वर्ट किया
फर्स्ट स्टेप क्या है फर्स्ट स्टेप
सर इंपोर्टिंग ए डेटा सेट टू द
पहले फर्स्ट स्टेप इज क्रिएशन ऑफ द प्रोजेक्ट
yeah created a new project then we selected a working directory okay and after selecting the working directory we imported the data set okay
yes.
After that we set our working directory in the console
okay so what you are saying project creation setting up working directory
yes फिर वो वर्किंग डायरेक्टरी के अंदर हमने
import the data so import the data
yes
import the data yes Manish इसके बाद क्या है
sir import the data
Manish Manish को आने दो
सर इंपोर्टिंग द डेटा के सेट के बाद में सर performing the data transformation means we are going to change the data type like if numeric is there like customer ID is in numeric and we have to transform it as a string like or character so converted it into a factor
so first then Manish then you call that stage is your data exploration okay and
that will
within that you will call that you will not call that as data transformation okay data transformation kisko bolte hain let us say you have income data and that is a very skewed data and you do logarithmic transformation okay that kind of operation you call it as data transformation you are changing form of the data इसमें क्या हो रहा है R ने कुछ तो डेटा रीड किया राइट हमने जेंडर का डेटा 1 2 दिया इनपुट लेकिन आर ने उसको न्यूमेरिक कंसीडर किया तो हम वी आर टेलिंग आर ओके दिस इज नॉट न्यूमेरिक डेटा बट दिस इज अ फैक्टर डेटा बट दैट इज नॉट डेटा ट्रांसफॉर्मेशन इज दैट फाइन मनीष एंड द क्लास if you have any question please ask me right so you are doing data exploration you are trying to identify how many observations you have you are trying to identify how many variables you have you are looking at data types that is the first step okay then what next Pratik
then after
Pratik sir then we analyze the data by using
what we are doing
initial exploratory data analysis and hello
yes
from initial exploratory data analysis for nominal data we use frequency distribution
yes
using table command then for numeric data we perform the summary analysis like summary standard deviation mean
basically we would like to know mean and standard deviation that will give me the data for the continuous variable right you can you can use summary command or you can use mean or standard deviation now as part of your exploratory data analysis Okay, the next thing to look at is to find out if there is any missing data. Okay, now the command for finding out the missing data. Just wait. Now, the first thing to know in R, the missing data is represented by NA value, right? So if in the CSV file, if you have NA value, okay, that data will be called, that point will be called as a missing value. Okay, and the command for that is dot NA. Okay, what you are asking is there a NA value in, let us say, data set dollar, what do you say, age? So run this command and tell me the output. What you are asking, is there a NA value in this particular column? This is the command and this is your input. Run the command and
most of the data, the output is showing is false, false, false. Reach the get option maximum.
Is there a problem, right? Is there a problem? You are not able to view all the values?
Yes, sir.
Right. So in that case, so additional command you will add. So you close the bracket and you ask tabulate this data. So table within bracket is dot NA, bracket dataset dollar age, bracket close, again the second bracket closed. Okay, so this becomes like this, is dot NA, dataset and run the command. Run the command and please post the command in the chat box after running. And tell me the output.
Set is false and number of to 1.
So which means we don't have any missing value in the column, in the variable.
Yes, sir.
Okay. Now, see, in this particular data set, there are no missing values. However, there will be data set. So I'll be sharing that the some data set which has missing values, and then how to handle such missing values. So if there is a missing value, what do you do? How do you handle missing values?
Sir, in that case, we will replace it with the average or zero or the most common or like mode of the row.
Right. So first is drop the observation.
Yes,
or
sir,
drop the
zero.
response, first step. The second is mean imputation. Okay, average और mean imputation. ये continuous variable के लिए हुआ, categorical variable के लिए क्या करते हैं?
So the most mode, sir.
Right, for categorical variable, you will find the mode and you will impute that value. You will replace that value, or then the other alternate approach is your regression imputation. So you will find out variable which has closest relationship with other variable, run the regression, predict the value and impute that value. Okay. So in this data set, so you run quickly, just take 2 to 3 minutes and run all that command and tell me if there are any missing values in the variable and post that code in the chat box. Only Pratik has posted the code. Please post the code in the chat box.
Sir, I have also posted the code.
Huh. Do that for other variables. So I'm posting the rest of the codes. Please copy this in your project and run this command. I am going to take random names now. Bhavuk, are you doing this? Bhavuk is there? Chandrasekhar,
Yes, sir.
are you doing this?
Yes, sir, I am doing so.
Okay, you have got the output?
No, sir, not yet.
Okay. Gautam,
Yes, sir. Yes.
are you doing this?
Yes, sir.
You have run the command. You have run all the commands as of now?
No, sir. I'm doing it by hands. I have run three commands. Three commands.
Okay. Okay.
I'll do the rest.
Yeah. So should I move?
Yes, sir.
Okay. Right. So the next step is to look at, do some kind of data visualization. Okay. Calculate skewness, kurtosis, and plot histogram and box plot. Okay.
Sir, can you please repeat?
Just now what I said.
Yes, sir. Yes, sir.
Okay. Okay. So then the next, after you have done your missing value analysis, probably you can again, if you are doing mean imputation, mean imputation, let us say you have imputed mean. After mean imputation, what would be the mean? Let us say before mean imputation, your average value is X. And then you have imputed all the missing values as X. What would be the resulting mean after mean imputation?
Same, sir.
Same.
Same,
X.
sir.
Right. So after mean imputation, it will be same. Okay. Right. So then the next.
Sir,
Yes.
sir, how exactly we will replace the NA value with the missing value with the mean or zero or something else? Like all the NAs or all the.
So Pratik, what I will, since this data does not have missing data, okay, so I will share one data set which has missing values, NA values, okay, and for that particular data set we will do an hands-on exercise as to how we identify the missing value and then how do we impute that missing value.
Okay, sir. Okay, sir.
Right. Okay. Right. So now the next step is data visualization. especially looking at the distribution, plotting the histogram, and let us say for continuous variable, looking at the box plot. Okay, how the distribution looks like, whether there is some kind of skew. Right. So how do you test the normality in the data? Batao. How do you test the normality assumption? Yes, Kaustubh, are you there? Kaustubh? Saqib?
Sir,
हम ग्राफ प्लॉट कर सकते हैं,
हाँ
ग्राफ प्लॉट करके देख सकते हैं.
हाँ, but how do you evaluate? What are the evaluation parameters for testing? One is graph plot.
Degree of,
Sir, central limit, sir. Mean, median, mode are the same or not?
One of the way is to look at mean and standard deviation. Probably that also an indication. But what are the other factor? What are the evaluation criteria? Do we look at skewness and kurtosis?
Yes, sir.
Right. So,
if
we look at the.
It is not evaluated.
Right. So we look at the skewness and the kurtosis. Okay. So skewness implies ये मेरा ग्राफ how symmetrical this data is. Okay. And kurtosis implies how peaked or flat this distribution is, peakedness or flatness. Okay. Now the package for calculating the skewness and the kurtosis is moments. There are other packages as well, but in this we will use moments. moments. So first install this package. Come here, click on packages, install, and search for moments. Click on this and click on install. ये करिए. Are you with me on this?
Yes, sir.
Okay. Now, to check whether this package has been successfully installed, the command is library, recalling the package. Recalling which package we want to test whether this package has been successfully installed or not, or whether there was some kind of a problem. Okay, so it has been successfully installed. Okay, you will write these commands here in the R console and run it. I am okay. These are the commands. Then calculating skewness. So this is the formula. Command kurtosis. Okay, and let us say you would like to calculate for age, kurtosis for age, and run this command. रन करके बताइए मुझे क्या वैल्यू है, और मुझे बताएगा कौन. आकाश, यू आर देयर? आकाश पालीवाल.
Sir, can you show the code? Skewness.
Right.
Sir, skewness is 0.699.
0.699. Okay.
2693.
So, and then what is the kurtosis value?
3.3470.
3.3470. Okay. Now, skewness, okay, values. Let us say minus 0.5 to 0.5. Okay, this is called as and very acceptable skewness values. Okay, you consider there is no problem. Then values between minus 1 to minus 0.5 and 1, so between 0.5 to 1, okay, we say there is some kind of skewness. Okay, if there is some skewness, the acceptable value is minus 1.96 to plus 1.96. If the values fall between these values, you can say, okay, there is reasonable, we can accept this skewness in the data. Okay, left skewness or right skewness. And same is the case with kurtosis. Okay, so we can say, now there are various books and statistics books, there are various scholars, right? Now for kurtosis, again the range is this value, but some of the statistics books also liberalize this value and say, okay, in some case it is 5, in some cases it is 7. Okay, but
moderately skewed होगा ना data?
Yes, moderately. So see, अगर ये value इसके बीच में है, we can say there is some skewness, but it is within acceptable levels. और अगर तुम वो in detail जाना चाह रहे हो तो वो it is falling here and you can say it is moderately skewed. All right? Okay?
सर मैं वो स्क्यूनेस वाला मोमेंट्स वाला ये पैकेज इंस्टॉल नहीं हो पा रहा, बट ऐसा है कि वो सक्सेसफुली, यस सर, वो सक्सेसफुली तो लिख दे रहा है कि इंस्टॉल हो गया, बट जब वो वैल्यू मैं निकालने जा रहा हूँ डेटा सेट का एज का, तो उसमें नहीं दिखा रहा है वो।
तुम्हारा स्क्रीन शेयर करो।
यस सर, सेम प्रॉब्लम मेरे साथ भी था, बट एक्चुअल में पैकेज नेम डिफरेंट है। E1071 पैकेज इंस्टॉल कर ले, हो जाएगा सर।
नहीं पहले वो लेट हिम जस्ट शो मी व्हाट ही इज डूइंग।
यस ओके सर।
सर देख रहे हैं सर? यस सर। तो सर मैंने
पहले पैकेज पे जाओ, सर्च करो। आपका आर कौन सा वर्जन है आपका?
सर ये तो पता नहीं सर। सही, मैंने मोमेंट्स लिखा है और फिर इंस्टॉल कर रहा हूँ।
ये यहाँ पे नीचे आकर के उसको ये कर दीजिए, सेलेक्ट कर दीजिए मोमेंट्स को, और इंस्टॉल कर दीजिए।
हाँ सर कर दिया।
रन फिर से रन कीजिए। अभी लाइब्रेरी मोमेंट्स ये कमांड रन कीजिए।
हाँ सर वो तो एक सेकेंड। लाइब्रेरी,
यस। आप जब टैब करेंगे ना तो आपको कंप्लीट कर देता है। यूज टैब, लाइब्रेरी टाइप करके टैब यूज करने का, जस्ट यूज टैब।
यस सर।
हो रहा है?
नहीं हो पा रहा सर।
अच्छा ठीक है, उस पर सिलेक्ट कर लो उसको, लाइब्रेरी कमांड को, फर्स्ट वन, उस पर क्लिक करो उस पर।
यस सर किया।
हाँ ठीक है। अब उसमें मोमेंट्स टाइप करो।
यस सर।
राइट, रन द कमांड। Okay, now run that skewness command. उसके ऊपर वाली जो लाइन है, जो आपने नहीं, वो क्या ऊपर लिखा हुआ है ना कमांड वो?
Yes.
Yeah, just run that command.
Yes sir, आ गया.
उसको आ गया ना?
Yes.
Right. Same way you calculate kurtosis. So remember this, whenever you have installed a new package, you will also recall that package, this library, using this command library. Okay, अगर कुछ भी गड़बड़ हुआ है and whether it has not been properly installed and if you are not getting an output, if this command runs successfully, you should get result.
So again
kurtosis spelling गलत कर दिया आपने.
Okay.
KUR.
Yes.
Run the command.
So आ गया sir, 3.34.
Right. And see, when you are writing these commands, you should create breaks and steps. So here you are doing exploratory data analysis and kind of a data visualization. Then you are doing missing value analysis. You are importing the data. So such sections you should create here. Okay. So that gives you an idea कि हमने क्या steps follow किया. All right. So quickly now calculate.
Sir.
Yes.
सर कर्टोसिस का सर एक्सेप्टेबल वैल्यू क्या था?
-1.96 to 1 plus 1.96 ये है एक्सेप्टेबल वैल्यू
था ना?
वो कर्टोसिस का भी यही है. See, this is like a Z value. Okay, -1.96 to plus 1.96. So then, but some scholars, some statisticians also liberalize this value. But if there, so there are some textbooks which says 5. There are some textbooks which says 7. Okay. Now, for us at this stage, we are saying कि kurtosis value में problem है. If we are going with -1.96 to 1.96, positive 1.96, Pratik. Okay. Now we will look at the histogram. We will plot the histogram and look at the distribution of the data.
Okay, sir.
Okay. So similar, let me share again my screen. Okay. Now you will do this kind of calculate skewness and kurtosis for all other numeric variables. Okay. Like balance. Okay. Then कौन कौन सा न्यूमेरिक वेरिएबल था आपका? बैलेंस वाज देयर, ड्यूरेशन वाज देयर, पी डेज वाज देयर एंड प्रीवियस वाज, campaign was also there, right? So I have a strong, right, balance would be the balance available in the account. That data would be heavily skewed. So you will calculate the skewness value and kurtosis value for all these numeric value variables. So just calculate the skewness and kurtosis values for these numeric variables.
So what's the desired value for skewness?
What is the
desired value for skewness?
Can you repeat?
Desired value for skewness.
Desired value is between -1.96 to positive 1.96. Okay. Now within that, what you say? Achha, let me write here. The value should fall between -1.96 to positive 1.96. Now, first point, okay, within this -0.5 to 0.5. If the value falls between this, you say, okay, slightly skewed. Then you have -1 to -0.5. Or 0.5 to 1, you say moderately skewed, right? And then third is your -1.96 to all the other positive 1.96. So if now this it is acceptable. You still accept the values. Okay, but see, generally आप ये देखना है -1.96 to +1.96. If the value falls between this, you accept, okay, the skewness is unacceptable for testing the normality assumption. Is that fine?
Yes, sir.
Okay. Calculate the rest and post the command in the chat box.
Sir, I posted the command.
Okay, great. आप जो लोग कर नहीं रहे हैं, you can copy this command, okay, and paste it in your R console and just run this command to see whether you are getting this output or not. Should I wait or should I move? Class.
Sir, move.
Others?
Move, sir.
Yes, sir. We can move
Prabhat, you have done? Prabhat, you have done?
Yes, sir. Yes, sir.
Akshay, you have done the command and ran the command?
Yes, sir.
What about others? Shamil? Shamil, are you there?
Yes, sir.
Okay, you have run the command?
Yes, sir.
Okay. Now the next is plotting the histogram. So the command for that, right, there is ggplot2 as well, but this is much simpler. So we'll learn this, and if time permits, we'll look at ggplot as well. So HIST, histogram. This is the command for plotting histogram. Data set. So run this command. This will give you the output in the form of a histogram here. Like this.
Sir, we have to plot histogram for all the variables, numeric variables.
Yes, yes, yes. That, but I'll just show you now the detail within that, some detailed aspects.
Sir, it's showing an error. They're showing that figure margins are too large.
For what age?
Sir, for histogram.
But you're plotting histogram for age?
Yes, sir.
Okay, just share your screen.
Yes, sir. Yes, sir. Can you see it now?
No.
Sir, is it visible?
Yes.
Yes, sir. So this is how it's showing.
Just calculate the mean and standard deviation for this data set age.
So,
for Shamil.
Select first plot in the right hand bottom side. Select the plot that will show.
SD.
Oh,
वो मनीष उसको एरर आ रहा है ना, ही इज नॉट गेटिंग द आउटपुट, वो कमांड रन नहीं हो रहा है. मनीष तुम्हारा एज का जो है ना ये मीन और एसडी कैलकुलेट करो, और यही एग्जैक्टली तुम्हारा भी है क्या चेक करो.
हाँ सर,
सेम है ना. तो ये
यस.
So I will see, Shamil, I'll see. We will discuss this outside the class.
Okay, sir.
Okay.
Sir, I think there will be a package issue. He must recall the package. That's why the error is showing.
Yes, yes. So I'll discuss that with him separately. Okay. Now, see, there are various now detailed aspects. You can beautify this graph as well. You can give some name. So I'll just show 1 or 2, 3 steps, and then we'll move to the next stage. Now, let us say you would like to give name to this plot. So the convention is main equals histogram. You can give whatever name that you would like to give. Histogram for age. Okay, and run this command like this. So the graph will take the name here now. Earlier it has not taken the name. Now it will take the name. Right, so this is the name. You can just give age as well.
Yes, sir. Got it, sir.
Okay. Then the next stage is your X lab, which means you would like to change the name of the X axis. Okay. So just copy this command once again. Here, give comma, enter, and X lab equals age. Okay, and run this command, and your name of the x-axis has changed here. Okay.
Yes, sir.
Right. Let us say you would like to color this histogram. Enter and color. Let us say you would like to give green as a color. Green. Right. So this changes the color of the histogram. Now, all the arguments that is there in this command that you give, right? You can easily find out using this function and just press S1. So all these details about this function will come here. Okay, so this is the input value. Then what we have given the name for XLab, right? We are also giving color, this command. This should be the color. We can also include the color of the borders and all those things. We can also include the range. How many? Let us say how many breaks we want. In the earlier plot, let us say there are around 10 breaks here, cells. Let us say we give 100 here. It has taken by default. So it will show us more distribution in the data. See this. It has given more breaks, more distribution, more distribution. It is showing us the distribution of the data. So all these commands you can change on a continuous basis. Now it's the same thing you will repeat for the other numeric data. I am just copying and pasting this code here in the chat box. आपको ये रिपीट करना है दूसरे वेरिएबल्स के लिए, दूसरे other continuous variables like balance and all those things. So, and there are more and more arguments which you can add, okay, and that gives aspects of organization.
Hello, sir.
Yes.
Can you explain the break part? What breaks do actually?
So Manish, just this for you run one command with breaks equal to 5, breaks equal to 10, and
Yes,
breaks
sir.
equal to 100, and see the output.
Yes, sir. Plot is changing, sir. Means
The number of
distribution.
cells, this
Yes, sir.
right in the histogram, they are increasing when you increase the number of bricks. Right, I am here changing 5. Right, so you have dominantly 1, 2, 3, 4, and 5 cells. So if you look at the description here also.
So it's majorly focusing on the number of bars that are
Yes.
visible in the plot.
See, Manish, यहाँ पे description में command के description में देखो breaks. What is breaks? Okay, it is either a vector, a function, or a single number. So we are giving a single number. Okay, and in the last 3 cases, the number is a suggestion, as the breakpoints will be set to pretty values. Okay, हमने 5 दिया ना, तो just to for looking it more pretty, it will adjust and give you the breaks around that 5 number. Now if we change this to 10, see this, from 5 breaks it has increased to 10 breaks. Now if we increase it to 100, all right?
Yes, sir. So
yes,
the higher number will be the better one, sir, because it gives us the better visualization.
Yes, so it depends on your objective, what you are trying to do. If you are just looking at histogram, then probably 10 bricks, but you want to look at the entire distribution, probably larger bricks is required. It completely depends upon your objective, what you are trying to look into the data.
Okay, sir. Got it, sir.
Right?
Yes, sir.
Yeah. Okay, and there are various detailed aspects you can incorporate. Okay. Okay. So then you will repeat the steps for all other variables. Now the next stage is the output that we were getting in summary. Plotting the box plot. Okay. So the command for that is box plot data set. So run this command. Run this command and you get a box plot like this. And for the same thing, you can add color, you can add other elements in this box plot. Are you fine with this? All right. So, yes. Right? Yeah. Yeah. Now, the next stage is your. Now we have done or complete. So you will do this in detail for all the other variables. Okay. And so we have kind of completed our exploratory data analysis, descriptive analysis, univariate analysis, analysis at the level of individual variables. Okay. Now the next stage is building our predictive. Build your, how many observations we have in this data set? How many observations we have? 4521. 4521. Okay. Now what we do, we split this data. We split this data. Okay. And we split and call this as train data and test data. Okay. In what proportion? It could be 50-50. It could be 70-30. It could be 60-40. Okay, again, that's your prerogative. If you have large data set, now with a large data set, you can go for 50-50. If you have small data set like this, 4,000 rows, you can probably choose to go with 70% of the data point in train data and 30% in your test data. Okay, so what you would like to do, you would like to split the data. Okay, so the command for that, to create, what we are doing, we are creating sample. So the command for that is sample. Now before you run this command, you have to also set a seed. When I say set a seed, and the command for that is set dot seed. Let us say 80. You can give any number. Now what does this imply? Whenever you will run this command with this seed, which means you are starting at a particular point to pick up the samples. You have 4,521 rows. Imagine that you are doing this exercise manually. Okay. And you want to ensure that whenever you repeat the exercise manually, you get the same sample. Okay. to get the same sample, you have to start at the same starting point. And to start at the same starting point and to get the sample again and again, if you repeat the exercise, the command for doing that is you set up a seed for picking up the sample when you run the command. Is that fine?
Sir, so simply set dot seed actually dividing the data set into the number of part, whatever we are trying to say.
It is not.
If 4, 5 to 1, say it's a 4, 5 to 1, and I'm set dot seed at 2000. Then the next data set 2001. That
See, it is like, let us say, have you heard of step random sampling?
no, sir.
See, step random sampling is, let us say you have 2000 data points and you want to pick up 100 samples from that 2000 data set. Okay. Now, one of the way is step random sampling, which means you decide every 10th element I will pick up. Okay.
Okay, sir. Got it, sir.
हाँ, so आप वो repeat करते हो. Every 10th element you are picking up. Okay, every 10th element you are picking up till the time you complete the 100 sample. Now, then the second question is, are you replacing that? Are you putting that sample back into that 2000 sample when you are creating 100 sample? If the answer is no, then replacement equal to true. There is no replacement. But if there is replacement, let us say you have, I will just show you, right? So आपके पास 2000 है. You want to create 100 ka sample from this 200. Let us say you have picked up A and put this A here. Now A is not available. So in that case, without replacement, replacement equal to true. That argument also you give. There is B. आपने A को train में डाल दिया. Let us say. Now you have taken test B in test. So A and B have been already allocated. Now again for the third time you will come here. A and B are not available because they have already been allocated.
Okay, sir.
Okay. So that's now let us say ये 2000 में 1, 10, 20, 30, 40 है. Right, like manually, if you are doing step random sampling and you have decided every 10th element. Okay, so this comes into your sample, this comes into your sample. Now, next day, rather than Manish, I ask Pratik to choose a sample which is exactly similar to Manish. So you will have to follow the same step, choose 10th element, and only then you will get the same sample as Manish. Just to ensure that you have this set.seed, you can give a random number which is less than the number of observations.
Okay, sir.
Okay.
Okay, sir.
Yes. Okay. So then the command for creating sample within bracket. How many samples you would like to create? How many data sets you would like to create? हमको ट्रेन और टेस्ट करना है तो कितने डेटा सेट हैं?
2, sir.
2, right? Then we will select the data set row wise, not column wise. So that argument we have to go give n row of which data set? Data. The name is data set. Okay. Then are you replacing? So is it without replacement or with replacement? There is no replacement. So the command is replace equals true.
False.
True, okay, true.
Yes,
okay.
Sir.
And then you want to assign probability or proportion. So then you have to give it as a vector in the form of a vector. So comma probability equals 70% in trained data and 30% in test data. Close this and close this entire bracket. Okay, so you run this command, you can assign this like probability of default or some name, and you run this command and see the sample. Now the detail of this command, again as I said, it is very easy to find out. There are various arguments that you can give. Search here. So this is the X that we are giving, number, right? Replace equal to true or replace equal to false. In our case, it is false. And here they are saying no probability, we are saying probability. So that's how this command works. Okay, you in detail, you will have this description about this particular command. So run this command, and again, so in the next class, we will continue, but just run this command. Yeah. What output you are getting, Manish? ये स्पेस रखा करो, ये जैसे ट्रू और प्रोबेबिलिटी में स्पेस है ना, वैसे जनरली कीप अ प्रैक्टिस, कीप अ हैबिट ऑफ कीपिंग द स्पेस. So what output you are getting?
So it will be number 1 to 1 to, and it means it's assigning the where the data is going. Like say, if it is 1 to 1, 1.
So see, we have given 2 as an input. So what it has done, it has assigned values to the rows as 1
Yes,
and
sir.
2, 1 and 2, 1 and 2. Then
Yes, sir.
the next step is to pick up that 1 values and assign it to train data, and pick up those 2 values and assign it to test data. We will see that in the next class.
Okay, sir.
Okay.
सर एंड ये एंड में भी कुछ आया, रीच्ड गेट ऑप्शन मैक्स प्रिंट.
शेयर करो, स्क्रीन शेयर करो.
Sir, actually I am using a phone for the class and laptop. Sir, but end में there is written omitted 3521 entries.
ये करो, यहाँ पे स्क्रीनशॉट तो डालो.
Sir, 1 minute, I will share.
Sir,
I have the same.
Sir, actually,
Sir, it's just not printing all the.
Yes, sir.
Yes, sir.
Yes, it's printing the entire values. See, उसके लिए what you do, you use command view. So you see, आप इसको ना, you assign that these values to some name, PD. I am saying probability of default, and use this command view PD. The entire values you will be able to. I'll just show you. Okay, so I am using this. I'm using this, and rather than printing this, what I'm doing, I'm just viewing this. So this is how it will look like. Are you fine with this?
Yes, sir.
Okay. You can actually, Manish, just use table command for this PD and see whether you get an output or not.
Sir, I got the same output after viewing the view option.
नहीं, अभी table PD करो, table in the bracket PD.
Sir, वो segregation दिखा रहा है 1 में कितने और 2 में कितने.
हाँ, right. So
yes, sir.
Right. So Right. So in one you have 3,173 sample observations, and in two you have 1,348. इसको आप proportion calculate करोगे ना, so you will realize, okay, this is 70%. ये क्या हो गया? You will realize this is 70% and this is 30%, because हमने यहाँ command दिया था कि पहले sample में 70% आना चाहिए, दूसरे sample में 30%. Okay, we will discuss this in detail again. All right. If you have any queries, please do write to me. We can discuss this one-on-one, but please ensure जो commands or codes हम run कर रहे हैं, you are also able to run that in your project.
Yes, sir.
Yes. So should we stop here?
Yes, sir.
Okay. Yeah. Thank you. Thank you all for your patience.
Can you please give the ownership of these two sessions, session 13 and...
So Pratik, can you again repeat the steps? I'll just close this recording first. वो पिछले वाले का तो दिया था पार्थ.